All right, so this video is going to take you through Chapter 3, Section 2, which is angles formed by parallel lines and transversals. So what you need to know is what are those special angles, what are alternate interior, alternate exterior, corresponding and same side interior. And then we're going to take it a step further and say if the lines are parallel, what does it mean about those angles? So this is the one of just going over the types of angles. So 5 and 7 are what kind of angles? Corresponding, good. 3 and 6? Alternate interior. And 1 and 8? Good. Alternate exterior. Everybody good on that, right? Okay, so now we're saying what happens if the lines that these are cut by are parallel? So every single postulate and theorem that you're learning today, God bless you, are going to start with the same words. If two parallel lines, or not same two words, but same words. If two parallel lines are cut by a transversal, then what? So this one says corresponding angles are congruent. So if the two lines that are cut by the third line, which is that transversal, are parallel, then all corresponding angle pairs are congruent. And this is called the corresponding angles postulate. So that number, that postulate 321, is not really of value, to be honest. It just means it's in Chapter 3, and it's Section 2, and it's the first postulate. What's more important is the name of this postulate. So corresponding angles postulate is that if the two lines are parallel, then the corresponding angles are congruent. Okay, all three of these are theorems. And again, they all start the same way. If two parallel lines are cut by a transversal, the alternate interior angles are congruent. The alternate exterior angles are congruent. And the only one that's not congruent is same side interior. Those are supplementary. So if the lines are parallel, you've got to know that they're parallel. Then you can say 4 things. Alternate exterior are congruent. Alternate interior are congruent. Corresponding are congruent. And same side interior are supplementary. What's supplementary mean? They add up to 1. Good. Add up to 180. So now you know everything you need to know from this section. All we have to do is apply it. Okay? So example 1 says the measure of 3 of the numbered angles is 120 degrees. Identify the angles and explain your reasoning. So which of the other angles has the same measure as 120?
5.
You said 5? 5, 8, and there's one more? 4. Why 4? They're vertical angles. Good. So we've got the vertical angles that are going to match. That makes 4 120. And then we've got alternate exterior, which would be 8, would be 120. And then we've got corresponding, which would make 5 120. So when you explain your reasoning, it's almost like a step in a proof, right? You would say angle 4 equals 120. And that's the vertical angles theorem, or VAT for short. Angle 8 equals 120. And that's the alternate exterior angles theorem. And angle 5 equals 120. And that's the corresponding angles postulate. So the corresponding one's the only one that's, oh, geez Louise, postulate. The only one that's a postulate is the corresponding one. So could you find the measures of 2, 3, 7, and 6?
Yes.
How?
Because they add up to 180, so you subtract 180 from 120.
Good. So the angle 2 and the angle 120 that they gave me would be a linear pair, right? That's going to add up to 180. I could say that 2 is 60. I could do the same thing with 120 and 3. Those would also be a linear pair, making 3 60. Or once I get that 2 is 60, this would be 60. That means this is 60 because it's a vertical angle. That means this is 60 because in respect to the 2, 7 has what relationship? 2 and 7 would be what? Alternate interior, right? How about 2 and 6? Corresponding. Or 7 and 6, what's the relationship there? Vertical. Good. So if you have 2 parallel lines and a transversal, it's going to form 8 angles. If you have one measure of an angle, then you can fill in the rest by all of those relationships. Braylon.
You have to like when you write it out, you just put for example, angle 4 equals 120. You just write the vertical angles, or you have to write theorem like that.
So the theorem is what tells you they're congruent. Vertical angles is technically just the definition. So you want to make sure you put the word theorem on the end of there. You can abbreviate that, like if you put VAT, because you're going to use those a lot. That would be vertical angles theorem. But the definition just tells you they are vertical angles. The theorem is what tells you they're congruent. Same thing for all of the ones we're talking about today. Alternate exterior angles are just alternate exterior angles. They're not necessarily congruent until the lines are parallel. Once you have that, then you have the word theorem on the end. You're saying that they are parallel. All right, so now we're going to pull in a little bit of algebra in with what we're learning, right? So this one says to find the value of x. How could you do it? Because there's more than one way.
3 would be 60 as well, right?
Well, x plus 5 would be equal to the angle above 4.
Okay.
So all you'd have to do is, since they're supplementary, you subtract 180 by 115, and that would be x plus 5.
Okay, so that's 65, right? So you're saying this one, these two are a linear pair, right? Okay, good. So that's 65, and then?
You subtract 5.
Good. So then these two are corresponding. X plus 5 would equal 65, and x would equal 60. Anybody see it differently? Because there's more than one way to do that. What about the relationship between the 115 and the 4? What's true about the 115 and the 4? They're vertical angles, which means 4 would also be 115. What's the relationship between 4 and x plus 5? They're supplementary because they're same side interior. Does everybody see that? And so then I could say that those two add up to 180. So you could have done it that way. I could have said 115 plus x plus 5 equals 180. And then I could have solved it. And then x equals 60. I wouldn't say one's better than the other. I would say it's whichever your brain tells you to do, because they're both right. You could have also said that this corresponds to this. So this is 115, and then these two add up to 180. So there's a lot of different ways to look at it, okay? One of the key factors in this diagram, though, is this little symbol here, which shows you that these lines are parallel. Without that symbol or a statement that says A is parallel to B, none of that is true. The lines have to be parallel in order for these relationships to be congruent or supplementary. Questions so far? Yep.
So 115 would be the angle for segment B.
So 115 on the other underside of B, is that what you're saying?
No, like where you have the green.
Yep.
And that would be 115 would be the whole line.
No, the whole line is 180. The 115, because it's 115 here, it's also 115 here, which would be corresponding. And then both of those together, because they form that line, would add up to 180. Does that make sense?
Yeah.
Okay. A little symbol jumped on top of the 1. So let's say the measure of angle 1 is 105. You want to find the measure of angle 4, 5, and 8, and then tell which postulate or theorem you used in each case. So this is a 3-part answer, and each part has an own explanation. All right, so I just put the 105 in where 1 is, right? What would be angle 4? 105. And why do you know that?
Vertical angle.
Good. Vertical angles theorem. How about angle 5?
105.
Also 105. This time why?
Corresponding.
Good. Corresponding angles postulate.
What is postulate?
Postulate's just something that comes before a theorem. Postulate's something that took the definition of lines, or whatever, in this case, lines and parallel lines, and somebody like literally loves geometry, kept drawing parallel lines, kept measuring what angles happen, and they developed a rule, okay? So postulate and theorem, honestly, the words don't really, you're not going to be tested on like what they mean, but what you should know is like, there's like definitions, which were obviously like established first, and then a postulate proven upon a definition, and then a theorem proven upon a postulate. So it's kind of like a stepping stone. That's all.
Do we know for the test?
What the difference is between theorem and postulate? No, but the names, yes. So you need to know that is the corresponding angles postulate. If you don't remember the name, then you write out that whole theorem that says if the lines are parallel, then the corresponding angles are congruent. So if you can't remember a name, but you can write out the actual theorem, I'm good with that, okay? As long as you know one or the other. Yeah. So 8 is what? 105, and why is that?
Alternate exterior.
Good. Alternate exterior angles theorem. Everybody good on those? Yep.
S, right?
That's in angles. Yeah, just plural angles.
Why would 4 be vertical angle?
Because look at the location of 1 and 4.
How come 8 isn't vertical?
Say again.
How come 8?
So 8 would be vertical to 5 if you're building upon 5. You can do it that way. But we're saying from the beginning, from each case, like separate them out. From only given the 1, I would say that it's alternate exterior angles. If you're building this in a proof or something like that and you're working off of the steps, then from 5 to 8, you can definitely use vertical angles theorem. Does that make sense? Yeah, okay. All right, last one. So it kind of puts the two things together. You got a little bit of algebra. Go ahead and find the value of x and then show your steps. All right, so I labeled what they gave me. Angle 3 was 68, and angle 8 is 2x plus 4. Now, there's a lot of different ways to do this, okay? I'm going to walk through one possibility. So what's the relationship between 3 and 7? They're corresponding, and if those lines are parallel, what's true about the measure of the angle? They're equal, okay? So I would say that 3 and 7 are congruent, that this is 68. What's the relationship between 7 and 8? Supplementary, which means 68 plus 2x plus 4 would equal 180, because that's the linear pair postulate, right? That's the linear pair says that two angles that form a line add up to 180. So then I'd get 2x plus 72 equals 180. Subtract 72, and I get 2x equals 108, and x equals 54. Good. Walk me through how you do it. Remember, there's a bunch of different ways to do it. So walk me through how you do it.
I did 180 minus 68
Okay.
is 112, and I knew that 2x plus 4 equals 112. So I did 112 minus 4, and I got 108, and then I divided that by 2 to get x, and I got 54.
That works. Anybody else do different angles, like not even the angles on the bottom? Because what's the relationship between 3 and 6? Alternate exterior, right? And then 6 and 8, linear pair, right? So there's a lot of different ways to do it. Sorry, go ahead.
Wouldn't 54 and 68 have to equal 180?
No, 54 is your x. So when you plug 54 back into here, that plus 68 has to add up to 180. So if I plug it back in, I get 108, 108 plus 4, 112, and that plus 68 equals 180. Questions on any of that? So you could actually make this into a proof, okay? I could have said Okay, given what I have, let's say that step 1 is the measure of angle 3 equals 68 and the measure of angle 8 equals 2x plus 4. What would be the reason for that step? Given. Okay, then I could say step 2, like work through the ones that I used. I could say that angle 3 equals angle 7, and we said what was the reason for that? Good, corresponding angles postulate. Then I can say that angle 7 plus angle 8 equals 180. What's that? Nope, I didn't use the word supplementary, right? What is it that tells us that 7 and 8 would add up to 180? What's special about 7 and 8? They are supplementary, but what makes them supplementary? They're a linear pair. Everybody see that? So that's the linear pair postulate.
Can you explain what a linear pair is?
Linear pair are two angles that the outside sides make a line. So like if you look at 7 and 8, they share the ray in the middle, and the outer angles form a line.
Oh, like they share a line, right?
Yeah.
Like
Mhm.
4, right?
Like 3 and 4, 2 and 4, 1 and 2, 1 and 3. All of them are linear pairs. So then I can say from there I can actually say angle 3 plus angle 8 equals 180. And what would that reason be? What happened from 3 to 4? Nope. So supplementary comes into play if I say it equals 180, so then it is supplementary, or if the word supplementary gets replaced with equals to 180. What happened from 3 to 4? Say again? Nope, but close. Substitution. We said 3 equals 7, yes? And in the place of the 7, I put 3. Does that make sense? So that would be substitution. And then I can say 68 plus 2x plus 4 equals 180. And where'd that come from? That's also substitution. Does everybody see that? Because I replaced the 3 with 68 and the 8 with 2x plus 4, which in the given I said was what they equaled. And then I could say, okay, this would be 2x plus 72 equals 180. What's that step? Simplify. Two x equals 108. What step's that? Subtraction. Property of equality. And 8x equals 54. Good. 7, so think what got you from here to here, right? You subtracted the 72. The next one would be the division property. So obviously you don't have to like do that full out, but just kind of think about how things could be used in proofs, because eventually you're going to be using these parallel lines in proofs a lot. Actually, the whole next section is called proving lines parallel. So we flip it. Yep.
So when we were doing the proof, when we were doing the question number 4, you said it was substitution. Would we get it wrong if we put like transitive division? If you look at it, like,
So transitive is saying if there's 3 objects, the first equals the second equals the third, so the first equals the third. If you are taking a value and replacing it with an object, or an object and replacing it with a value, that's substitution. But if I'm saying this desk weighs the same as this desk, and this desk weighs the same as that desk, so then this desk must weigh the same as that, that's transitive. Does that make sense? But if I said this desk weighs 35 pounds, this desk equals this desk, so then this one must weigh 35 pounds. I've replaced it with a value. That's substitution.
The reason I'm getting confused because it says like 3 equals 7.
Yep.
7 equals 8. Or
Okay, so along that line, if I had said 3 equals 7 and 7 equals 8, then 3 equals 8, that's transitive.
Oh, never mind.
Do you see what I'm saying?
Oh, I missed it.
4 and
Okay.
5 are both substitution, right?
So 4 and 5 are both substitution. In 4, we took the 7 and replaced it with the 3. And in 5, we took the 3, replaced it with the 68, and the 8, and replaced it with the 2x plus 4.
Sorry, thank you.
You're welcome.